Welcome to the Chemistry Talk Show with your host, Mary Nguyen.
Hey guys, today's topic is fire bubbles. Now, what on earth are fire bubbles? Let's roll the clip.
It was at this moment that he knew. He up.
Wait. Hang on a second. Let's watch that again. That, my friends, is where the magic happens. Those bubbles may look like ordinary soap and water bubbles, but actually, they're filled with methane. Methane. Well, the formula for methane is CH4, and the gas is both invisible and odorless. And on a less serious note, if you guys haven't thought of it already, cows are known to fart out a lot of this stuff.
You know, Uranus has a lot of methane in its atmosphere. Get it? Because Uranus, the planet, and we're talking about farts? No? Okay.
Hello, darkness, my old friend.
Anyways, cows excrete a lot of methane. 5 to 10% can be found in their flatulence, and the greater 90 to 95% can be found in their burps.
Besides cows, where can we find methane?
Methane is actually a natural source. There are pockets of methane that can be found in the ground, like what we're seeing here. These pockets form by the decay of natural materials and is commonly found in landfills, marshes, and sewers.
How much methane is found in our environment then?
Only a small portion of our atmosphere is methane, as little as 0.00017%. So, there is much less methane in the atmosphere than carbon dioxide. Both of these gases are known as greenhouse gases and are the causes of global warming. However, even if there's less methane than carbon dioxide in the atmosphere, methane's potential for global warming is 25 times greater than carbon dioxide. Yeah, that's right. Cows are responsible for the death of polar bears. Now that we've covered the background info for methane, let's get back to why methane plays such a big part in this experiment. Methane is mainly used as fuel to produce heat and light, and as you see in this video, it caused the bubbles to ignite when it was introduced to a heat source, of which, in this case, being the flame of the candle.
You know, Mary, there's a way you can amp up this experiment.
Oh yes, there is. We can take this up to fire-bending level. Fire Nation will be proud.
But, we still need help from water.
That would be so cool. Oh, you guys are still here. Alright, I was thinking, there's a way to recreate the fire in the plastic container onto your hand. Yeah, crazy, right? It's gonna look a little something like this. Wanna see some magic? How is that possible? Your hand didn't burn off? Yeah, my hand's still perfectly fine. Simple. I dipped my hand into a tub of water to coat it with a thin layer of protection. It's like a water shield, protecting my hand from the flame. We can relate this to another experiment, the fireproof balloon! A regular balloon over a candle flame is sure to pop. But if we fill the insides with water, the balloon won't pop over the candle flame. This is because of water's specific heat capacity. Water has to absorb 4.184 joules of energy for the temperature of 1 gram of water to increase 1 degree Celsius. Basically, water is a great heat conductor. It literally takes the heat away from my hands, at least for the few seconds that the bubbles are on fire. As a flame heats the water on my hand, some of the water at the very surface evaporates, and it's that natural cooling process from the evaporation that keeps my hand from burning off. Just to put it in perspective, a candle burns at 1,000 degrees Celsius, while methane burns at 1,957 degrees Celsius. Nearly double the amount!
Oh great, you're gonna be having that on your hand?
It's all good. I got the protection of water.
Don't forget it, you wouldn't want to look like Anakin Skywalker post-lava pit. Woo! You've made it to the end of this video.
To some of the things we've talked about, we've learned the basic facts about methane,
How methane is the cause of the flames and the bubbles.
and why water is super important to protecting your hands in this experiment.
We hope you enjoyed this cringy video.
And don't forget, cows are evil. Bye!